Hi, I'm Joe James. In this video, I'm going to teach you what a factorial is and how to calculate factorials. And then I'm going to show you how to use factorials to calculate permutations and combinations and solve those problems you're going to find on the SAT and ACT tests. A factorial is denoted with the symbol exclamation point right here. So in factorial is in exclamation point. And it's the product of all positive integers less than or equal to n. We can ignore the 1. I wrote it on here, but that doesn't change anything because 1 times anything is itself. So really, 4 factorial is equal to 4 times 3 times 2, which multiplies out to 24. So let's try and calculate 5 factorial. Well, let's see. 5 factorial, we're going to write it as 5 exclamation point equals 5 times 4 times 3 times 2, and we'll ignore the 1. So when we multiply this out, 5 times 4 is 20, times 3 is 60, times 2 is 120. So 5 factorial is 120. Now let's figure out 6 factorial. Well, 6 factorial is equal to 6 times 5 times 4 times 3 times 2. Which is the same as, well, see, this here is 5 factorial, right? So it's really 6 times 5 factorial. 6 times 5 factorial, right? So this is 5 factorial right here. So 6 times 5 factorial is 6 times 120, and that is equal to 720. So it's pretty easy to calculate factorials. It's really just adding more numbers out in front and multiplying them out. Now let's see how we can use factorials to solve problems. Permutations are the number of different ways you can arrange in items. And order matters. You'll see what this means in a second. So the first rule here, the first formula we're going to learn is the number of permutations of in items is equal to in factorial. That's a really easy equation, isn't it? So how many permutations are there for 3 items? Gee, this should be a piece of cake. 3 items, the number of permutations for 3 items is just equal to 3 factorial, isn't it? Which is 3 times 2. Again, we can ignore the 1. And that is 6. Wow, that was really simple. So 3 times 2 times 1 equals 6. And if you want to see that visually here, let's say our 3 items are A, B, and C. The 6 different permutations of A, B, C, these 3 items, are A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So what do we mean when we say that order matters? Well, look, we have the same 3 items in actually all 6 of these different permutations, but they're just arranged in different orders. So if order didn't matter, these would all be the same thing. But since order does matter, we've got the same 6 items arranged in 6 different orders. So we count this as 6 different permutations. So a permutation is an arrangement in order of items in a different order. And the items needn't necessarily be letters. Here we use just letters as an example, but they could be anything really. Formula here. So our second formula here is the number of permutations of k items chosen from a set of n items. This is an n choose k permutations problem because we want to know the number of permutations of k items chosen from a set of n items. For example, if we have a box of 10 toys and we choose 6 of those toys, how many different orders of items are there? Well, let's see. N factorial over n minus k in parentheses factorial. So let's use that to solve some problems. How many permutations are there for choose 2 items from a total of 4 items? Well, all we have to do is apply that formula we just learned. So the number of permutations of, let's see, what is n here? N is equal to 4, right? Because there are 4 items. There are a total of 4 items. So n is equal to 4. That's the number of items. K is the number of items we're going to choose, and we're going to choose 2 items, so K is equal to 2. Now we just need to plug that into our formula. Our formula was the number of permutations is equal to n factorial over n minus k factorial. And that's equal to 4 factorial, or we can write it out as 4 times 3 times 2 times 1, divided by n minus k. Well, that's 4 minus 2, right? Let's write 4 minus 2 factorial. So 4 minus 2 is 2. So this is really just 2 times 1 down on the bottom, isn't it? Let's write that out. 4 times 3 times 2, we can ignore that one, divided by, this is 2 factorial, which is just 2, really. 2 factorial is just 2. So that's our answer here. The 2's cancel each other out, and we just get 12. So that is 12. So the number of permutations, if we choose 2 items from a set of 4 items, is 12. There are 12 possible permutations. And if you need to see that visually here, look. If our items are A, B, C, and D, and we have to choose 2 items, these are all the different possible permutations of those 4 letters. So A, B, and then of course B, A. Again, order matters, right? So different order, same 2 items. These count as 2 separate permutations. C, A, and then of course A, C. So these are our 12 possible permutations for those 4 items. And our third and final formula here that we're going to learn in this video is the number of possible combinations of n items where order does not matter. And the formula for that is exactly the same as formula number 2, except that what we did is we added a k factorial in the denominator. So this is also n choose k, but this is combinations, not permutations. Let's take a look at a sample problem for combinations using this formula we just learned. So how many different combinations are there if we choose 3 items from the set A, B, C, D? So here we have 4 items, right? So n is equal to 4. And how many items are we going to choose? Well, we're going to choose 3, right? So k is equal to 3. So our formula is combinations is equal to n factorial over k factorial times n minus k factorial. So that's our formula. Now we can just plug in 3 and 4 for n and k. And we're going to get, let's see, 4 factorial, which let's multiply this out. 4 times 3 times 2. Sometimes it helps to write it out as 4 times 3 times 2 because you can cancel out a lot of stuff in the numerator and denominator. It makes it math a little easier at the end. K factorial is 3 times 2, right? That's 3 factorial, so it's 3 times 2. And then n minus k is 4 minus 3. Well, that's just 1, isn't it? So that's what we get for n factorial over k factorial times n minus k factorial. So there are this many combinations. And look, the 3 and the 2, that 3 cancels out with this 3, and this 2 cancels out with this 2. So what we get is just 4 over 1, which is simply 4. So there are 4 different combinations. So this whole thing just reduces to 4. And you see why I write them out like this. You can write it as 4 factorial, and then you can do the long math and then reduce your fraction. That's just a little more work. It's easier to just reduce stuff after you write the problem out like this. So here are the actual combinations: ABC, ABD, ACD, and BCD. So we don't get to write BAC, BCA. We don't get to write all these same items, different order, because those would be permutations. These are combinations. Each of these is a unique set of items. So those are the 3 formulas. You realize when you're looking for combinations where order doesn't matter, you just add this k factorial on the bottom, and that gives us combinations where order doesn't matter. If order does matter, you just scratch that k factorial off the bottom. So there are 2 different types of n choose k problems. What you need to figure out when you're looking at a problem is whether or not order makes a difference in the question they're asking you. So to summarize here, these are the three formulas that we've covered. Number one is the number of permutations of n items. We're not doing any choosing here, so there is no k. There's just the number of permutations of n items. Does order matter? Yes. Two is the number of permutations of k items chosen from a set of n items. And that's n factorial over n minus k factorial. And again, order does matter because these are both permutations, number one and two. Number three is combinations, where order does not matter. So the difference in the formula here is that we added the k factorial on the bottom because order does not matter. So those are our three formulas. Now when we see a problem, we just need to determine which one of these to use. It's going to be easy to rule out number one if we're given a k or we're not given a k. So if we're just given a number of items and asked how many different combinations or permutations, or it doesn't matter what they call it, if you're only given a number of items and you're not choosing any of those items, then pretty much all we can calculate is n factorial. If we're choosing a subset of a given set of items, in other words, there's both an n and a k given in the problem, then we just need to figure out if they want us to count the same items in different orders as two separate permutations. And if they count that as two separate entries, then that is this equation. And if you don't double count those, then we're looking for combinations, number three. So three formulas, not that complicated. But let's go ahead and apply those to try and solve about 3 or 4 problems here. First one, how many different possibilities are there? We'll just call it possibilities. We have to decide whether this is combinations or permutations. If we choose 4 people from the group John, Paul, George, Ringo, Brian, and Yoko, how many names do we have here first? 1, 2, 3, 4, 5, 6. Looks like we have 6 names. So n is the number of names in that set, which is 6. And then it says we're going to choose 4. So k is equal to the number we're going to choose, which is 4. That's our subset. And then they're asking us how many different possibilities are there. Well, does order matter? In other words, is John, Paul, George, and Ringo the same as John, Paul, Ringo, and George? Yeah, they're the same. Order doesn't matter. We're not lining people up. We're just choosing subsets of these. So since order does not matter, let's see. We want the combinations one, which is n factorial over k factorial times n minus k factorial. And that is equal to 6 factorial. I'll write this out. 6 times 5 times 4 times 3 times 2 divided by k factorial, which is 4. Let's see, 4 times 3 times 2. And then n minus k factorial, 6 minus 4. So that's 2 factorial, right? You have 6 minus 4, so that's 2 factorial in here. And 2 factorial is just 2. So that is it. Our n minus k factorial is just 2. So now we can do some cancellation before we do any multiplying. So we can cancel out this 2 and this 2, this 3 and this 3, this 4 and this 4. And what we get is 6 times 5 divided by 2, divided by 2. That's 30 over 2, and that gives us 15. So 15 different possibilities, or 15 different combinations of 4 names chosen from this set of 6 names. Let us try another problem. Sarika has 7 different types of flowers in her shop. How many different bouquets can she make if she wants 5 different flowers in an arrangement? Well, okay, let's first figure out what n is. N is the total number of items in the set, and in this case an item is a different species of flower. And she has, it looks like 7. So n is 7. And then how many is she going to choose for each bouquet? Well, it looks like 5. So the number she chooses is called k, that's our variable, k. K is equal to 5. So we have n and k we need to decide whether or not order matters here. She's arranging flowers in a bouquet. Order does not matter. What we're going to do is find out what combinations is equal to n factorial over k factorial times n minus k factorial. And we just plug in our numbers, calculate this. So let's see, here we get 7 times 6 times 5 times 4 times 3 times 2 divided by k factorial is 5 times 4 times 3 times 2. So all of this is going to cancel out. All of this is going to cancel out, isn't it? Scratch that, scratch that. And then we still, on the bottom, need to write n minus k factorial, which is 7 minus 5 factorial. So 7 minus 5 factorial. And that is 2. That's 2 factorial. So what we get, again, is pretty simple here. 7 times 6 is 42 over 2. And that is 21. So our answer here is 21. That whole thing works out to 21 different flower arrangements. Let's try another one. Theresa's favorite word is impact. I don't know why. That's kind of weird, but whatever. How many possible ways are there to arrange the letters of impact if all 6 letters must be used? Is she choosing a subset of those letters? No. Is there any value given for k? No. So all we're given is a 6-letter word, and we want to know how many different possible ways there are to arrange. That should be a clue, this keyword here, arrange, those letters. So this is just n factorial. This is permutations. We're looking for permutations of 6-letter word, and that's going to be equal to 6 factorial. So that is equal to 6 times 5 times 4 times 3 times 2, and we actually already did this earlier in the presentation here. That multiplies out to 720. So that one was pretty easy. And our final problem here, the math club, which has 8 members, must elect a president and a vice president. How many combinations are possible? Okay, they call it combinations, but that doesn't necessarily mean that it's combinations. So let's see, first let's figure out what n is. N is equal to the number of members here. We have a total set of 8 people, so n is 8. K is, let's see, there's a president and a vice president, so I'm going to say K is 2. Our subset size is 2. Next thing we need to determine, does order matter? Well, if Bob is president and Jenny is vice president, that's not the same thing as Jenny is president and Bob is vice president. So in this case, order does matter. So what we're looking for is permutations, not combinations, right? Because these are 2 different positions. If we were just selecting 2 board members, maybe we would use the combinations formula. But in this case, we have a president and a vice president, which are 2 different positions in the organization. So we want to know how many different combinations are possible. What we're really looking for is permutations. So let's figure out the formula here for permutations. Let's see, that's n factorial over n minus k factorial. And that is equal to 8 factorial, or 8 times 7 times 6 times 5 times 4 times 3 times 2 divided by, what's n minus k? It's 8 minus 2, which is 6 factorial. 6 factorial. In other words, all of this cancels out, and we get just 7 times 8, and nothing left on the bottom. So we get 56. 7 times 8 is 56. So there are 56 different, the right word for this is permutations. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.